Here's another question, grade 11. It's a different problem than the one that I've done on electrostatics. It said a sphere Y carrying an unknown charge, here's sphere Y, is suspended at the end of a light in an extensible string which is attached to the bottom, attached to a fixed point. Another sphere X carrying a charge of positive 6 microcoulomb on an insulated stand is brought close to the sphere Y. So this initially it was suspended, which is Y. It was suspended there, and then sphere X was brought close, and then it moved to that position, which is that position. Now it says sphere Y experiences an electrostatic force and then comes to rest 0.2 meter away from sphere X, and which the string is at an angle of 10 with the vertical as shown in the diagram. In the diagram below. Now, guys, these two, there's an electrostatic force between the two, but looking at it, this is repelled, it's pushed in that direction by this one. So if this one is positive, surely this one is a like charge, which is it's positive as well, right? And 7.1.1, what is the nature of the charge on sphere Y? Choose positive or negative. Guys, as I've mentioned, this is supposed to be positive, and then it experiences an electrostatic force, that one in that direction, so it has to be positive, right? 7.1.2, it says calculate the magnitude of the charged sphere Y if the magnitude of electrostatic force is 3.05. So 7.1.2, so if the electrostatic force between the two, Q2 is that, so we substitute the electrostatic force, we want the charge Y, so this is going to be 3.05, and then K, it's 9 times 10 to the power 9, and then this is sphere X, so we'll say 6.6 times 10 to the power negative 6, and then this will be sphere Y, right? Sphere Y, the one that we want, and at the distance between them, the electrostatic force is 0.2 square, and then if we do the math there, and then we cross multiply and all that, so the charge Y will be 2,26 times 10 to the power negative 6 coulombs. That's the charge Y, this charge here, right? 7.1.3, it says draw a label free body diagram for sphere Y. It's very important, guys, to understand what are the forces acting on sphere Y. The forces acting on sphere Y, guys, is the tension force in that direction. We have a gravitational force downwards, and we have an electrostatic force. This is a tension force and gravitational force and an electrostatic force in that. So, drawing a free body diagram, 7.1.3, it's going to be the tensile force there, the gravitational force downwards, and the electrostatic force due to X, right? That's the free body diagram there. 7.14, it says calculate the magnitude of tension. 7.1.4, the magnitude of tension there, guys, if we can draw here a vector diagram, we'll have that, which is this is a tension, and this is the gravitational force, and this is the electrostatic force. This is a closed vector diagram because that it's at rest. Let's say it's at rest at 0.2 and comes to rest at 0.2. So this sphere Y, it's at rest there, it's at equilibrium. So the angle there is what is 10, so that means the 10 degrees there, and that if it's 10 degrees, that means this is what, 80. So they want the tension here. What do we have Do we have the gravitational force? No. But they require for us to calculate the tension. We only have that. So what we're going to do mathematically there, what are we going to do? We'll use we'll say F net is equal to 0 because this is at equilibrium, right? And then if you look here carefully, we have, okay, let me redraw here. We have this tension here, and at this tension it has the forces that are acting here, it's the gravitation, it's the electrostatic force, and the Tx here. There's a component which is Tx in that direction there, right? We have a Tx in that direction there, and so the forces that are acting here are these two, and they are at equilibrium. So we'll say it's the negative Tx plus the electrostatic force equal to 0. So we'll say Tx is equal to, or we'll say the electrostatic force is equal to the horizontal component of the tension force, which is, it's going to be T cos theta, and then we substitute there. And then the electrostatic force we have is 3.05, and then the tension is the one that we want, so it's going to be cos what? Since it's this angle, so this is going to be what? 80 there. So it's going to be cos 80 degrees. So if we divide by cos 80 degrees both sides, cos 80 degrees, it's going to be, T is going to be equal to 17.56 newtons. That's the tension force there. Guys, you must be mindful, you can't use cos 10. If you use cos 10, you won't get max instead of cos 180, because the component of this we have the vertical, which is Ty, and we have the Tx there, right? So the angle between them, it's 80. So it will be the vertical. So if you use sine 10, you'll be fine as well. If you use sine 10 instead of cos 80, you can use sine 10. It will give the same answer. Cheers, bye.